Hey everyone, so today we want to go over Module 3, Chapter 14, the basics of probability. And I'm Heather,
I'm Skylar.
and let's get into it. Skylar, are you going to ask the question?
Using the diagrams, can you show 6 spots on the 2 dice? Heather.
So we created this diagram, and what it shows is a red dice and a green die, and the probabilities of rolling a 1 through a 6. So here I have highlighted in blue all of the possibilities of it showing 6 dice. So you have the 1 and 5, which equals 6, 2 and 4 equals 6, and so on. And those are the only possibilities of the red and green die together showing 6 spots. So, Skylar, I showed the 6 spots. Is there any way of showing 9 or more?
Yes, okay, so if you look at the middle diagram, it has yellow highlights on it because I couldn't make the circle because it wasn't gonna work. Anyway, so it says 9 or more. So if you look at 6 and 3 is 9, 5 and 4 is 9, 4 and 5, 2 and 6. Not 2 and 6. 2 and 6 is 8. Anyway, and then you have this entire, basically like you got 4 and 6, 5 and 5. Those are all 9 or more. And then for our next question, it asks if what was it to show if the red die only had 5. That's my question, right? And so it's circled and highlighted. So the red die, the front number is all of them are 5, and then the green is the second number, and all of them it's 1, 2, 3, 4, 5, 6.
Okay, and so after showing those, which two of the diagrams though are mutually exclusive?
So mutually exclusive means they cannot happen at the same time. So you can't have 6 total and 9 or more on 2 dice. Die is 1. So on 2 dice. So if you look over here at your far right at this diagram, it's got blue on. It's got a blue highlighted, and that's showing 6 or more. And then you've got the gray, which is showing 9 or more. And so they're basically parallel to each other. They never overlap or intersect, meaning that it cannot happen at the same time.
Wow, okay.
Okay, and then by using the formula, can you demonstrate the probability that the number selected is greater than 89 and even or and comma even or less than 32?
Okay, so the formula that we're using is PE equals NE over NS, which is very confusing if you don't know what you're looking at. So S is going to be your sample space. It's all your numbers included that are included in the whole question. And E is the event. So your sample space in the following problems is always going to be 100 for this example. So anywhere you see NS, you're just going to go ahead and plug in 100. And then your event is going to change versus what you're looking at. So like for the greater than 89, your event is going to be 99 minus 89 because you're looking to see what's greater than 89. So it's going to be 10. So if NE equals 10 and NS equals 100, you have 10 divided by 100, which gives you 0.110. So about 10% of that is greater than 89. And then you're going to look at the even or less than 32. And so the equation is PE or F because you're looking at it or not and. But if you see, you have the end in it too as well. So you've got to find what digits go for E, F, and E and F. So E is going to be the event, means it's even because you're looking for even or less. So NE is going to equal 50. And F is the number that is less than 32. So F is going to equal 32. You'll just plug those numbers into the equation. So P, E, and F are going to be 32 divided by 2, which equals 16. And then you're going to plug those into the equation. And here you have them all in fractions, but it makes it a whole lot easier if you go ahead and make these fractions into decimals. And so you have 0.5 plus 0.32 minus 0.16. And your answer for the probability of E or F is going to be 0.66. Now, in this equation, we already found the even and less than 32 as well. And so that is going to be 0.16 is your and less than 32. You got to watch the wording on whether you're looking for the or the and. And so it kind of can get a little bit confusing. But other than that, Skylar, can you tell us how to get less than 15, a multiple of 4, and the even given that it is less than 32?
Yes. So less than 15, so you have double zero all the way to 14, which are 15 total numbers. So your NE total number is so your total number in the event is 15, and like Heather said earlier, your sample space or NS will always be 100. So the probability of this event happening is 15 over 100, or you could simplify it to 3/20ths or 15%, or even 0.15 if you wanted. And then for a multiple of 4, so you have like multiples of 4 is like 4, 8, 12, so on and so forth. And in that, there are 24 total numbers. And so your total number in the event is 24, sample space is 100, and then so the probability of the event is 24 over 100, 24%, or 0.24. And then even giving that it is less than 32 is going to be I don't remember. Are you gonna help me out on that one?
Is that the, we didn't put that one in, did we?
Hold on. I will figure it out.
It's okay. We're in technical difficulties right now.
Minor problems.
How do I get out of that?
I don't have that.
Hold on, we're gonna pull another one up real quick.
I'm pretty sure it's the point like 1.5 or the 0.50 minus the 6.16, and it's like 32 or something like that. But
okay, so can you see that screen? Okay, so I pulled up the other one. So what you're looking at here is a whole brand new equation, and so you're gonna have you want the even given that it is less than 32. So your A on this part is going to be 32 over 100, so 0.32. And your A and B is going to be 0.16, same as the E and F. So the probability is the same, it's just different letters used in the equation. So what you'll do is take the 0.16 and then divide that by the 0.32. So the probability of the even given that it is less than 32 is going to be 0.50
or 50%.
or 50%. So then we're going to go back here.
Back to the original presentation.
And we will go.
Okay, so how can you calculate the probability that a randomly chosen student is less than 5 foot?
Okay, so we were given like all these like inches of the students. So you have an equation of px equals number of times outcome of x occurs and the number of times divided number of trials of the experiment. When we're given the numbers of students, we have 20 students, and we want to convert the feet into inches. I'm pretty sure I meant inches into feet, but you're going to do, no, it is feet into inches. So 5 foot times 12 inches over foot is going to equal 60 inches. So when we were given all the data, we constructed a diagram, which I'm going to show right here to your left, of all the inches of the students that were given of the 20. And what I did is I went ahead and put them in numerical order so it's a lot easier to read. And what we're looking for is any of the students that are less than 5 feet tall. So since we know that 5 foot equals 60 inches, that means anything under 60 is under 5 feet. And so here we have 3 students that are under 5 foot. And so the probability is going to be px equals 3 over 20. So about 15% of the students are under 5 foot. Another thing we wanted to look at is how many students were 5 foot 6 inches. So again, if 5 feet is 60, add 6 more inches, you have 66. If you look right here in this dark blue, it shows that one student is actually 5 foot 6. And so the probability is going to be 1 over 20, which equals 0.05. Along with looking at who is under 5 foot and who's 5 foot 6, Skylar, can you show us who is more than 5 feet tall?
Yes. Okay, so whoa. So I did my diagram just slightly different only because I didn't like the way that Excel showed the diagram. So I just did mine like 56 inches is 4 foot 8 inches. That way it didn't look all confusing. But so for my part, which is more than 5 feet tall, if you look at 61 inches is 5 foot 1. So that's where you would start. And so you count all of those kids. So there are 15 students in that class out of the 20 that are 5 foot tall or more than 5 foot tall. And so that's actually 75% of the students, or 0.75, that are actually taller than the rest.
I like the way you showed yours because I get confused.
Oh, I was looking at that and I did not understand what it was saying. So
No, I like yours. So, Skylar, also, so when we're looking at a class here, it says that there's 25 or 27 students in her class, and they speak 2 different languages. Can you tell me how many speak English and how many speak Japanese?
yes, okay, so 20 students speak English. This was given information to us. 20 students speak English, and then 12 students speak Japanese. Just that's plain, it's given to us. But Heather, could you tell me how many speak both English and Japanese, and how many speak only English?
Okay, so with the information that you gave, it said that 20 spoke English and 17 or 12 spoke Japanese. Well, that doesn't give us enough information. So we know here in this equation that we're looking for, we want to know how many speak English and Japanese. So the total class is 27. So A or B equals 27. So that's English or Japanese. And then you have 27 equals 20 that speak English and 12 that speak Japanese. Then you want to subtract the ones that speak, both. Here, or what we're looking for is which ones speak both. So you're going to move this part of the equation to the left side. And so you'll have 27 plus n, a and b equals 20 plus 12. But you want this part to be by itself, so you will go ahead and subtract 27 from both sides. And what you get is that 5 students speak both English and Japanese. And since we know that, again, there were 27 students, 5 of them, or 20 of them spoke English. If 20 spoke English, but 5 of those speak Japanese as well, it means that 15 students speak only English in her class.
Using the digits 1 through 7, could you create a table or diagram to show the following scenarios, Heather?
Okay, so in this one, what we're going to do is repetition of the digits is not allowed. So we're looking for 3-digit numbers that can be formed from the digits 1 through 7. So you have 7 choices for your first digit. Once you find that digit, you're going to have to subtract 1 because you can't use that same digit over again. So your second digit is going to have 6 choices. And then we're looking for a third, which is going to have 5 choices. Again, you just have to remember you can't use the same number over again. So that's why we're subtracting 1 from each of the choices. So what you would do here is you would, as you see in this little diagram, digit 1 has 7 choices, digit 2 has 6, digit 3 has 5. You would multiply all 3 of those together, and you have 210 options for 3-digit numbers as long as repetition is not allowed. And then we want to also look, so say you had to begin with either a 2, 3, or 4. So your first option has 3 numbers. That's it. You can start with a 2, 3, or 4. Nothing else. Well, since we already know there's 3 options there, your second digit is going to be 7 minus 1, because again, you already picked 1 of those numbers. So your second digit has 6 numbers, and your third digit is again going to have 5 numbers. So like before, we multiplied them together. You're going to multiply 3 times 6 times 5, which gives you 90 options for your 3-digit numbers, as long as they start with 2, 3, or 4. Skylar, I showed how you do it with starting with 2, 3, or 4. Can you show us how many of the numbers in the part are even?
Yes. Okay. Whoa. So your last digit here, like this green one, if you were to look like in the middle of this crazy thing, the green one, you can either use 2, 4, or 6. Those are your only even numbers. So like Heather had in the previous, instead of having 3 numbers to choose from in the front, you only have 3 numbers to choose from in the back. So since you've already used 1 number in the back, you can only have 6 options for the first number, and you can only have 5 options for the second number. So for how many are even, it's 6 for the first number times 5 for the second number times 3 for your last number. So you only get 90 possibilities that they're even.
Cool.
So cool. I love math. Okay, so how many different licenses can be made with either 2 letters followed by 3 digits or 3 digits followed by 2 letters?
So I didn't erase that S either. You're not alone. Okay, so first off, you need to know we're going to look at 2 letters followed by 3 digits. There are 26 letters in the alphabet, so you can choose from any of them. And since in this example, I'm going to show when repetition is allowed, meaning I can pick this, it can be A, B, B, anything like that. So my alphabet is going to be 26 letters for both options. So you'll have 26 times 26 or 26 squared, which equals 676. Same for the 3 digits. If I wanted it to be 111, I have the option to do it because repetition is allowed on this one. So you have 10 choices for all 3 digits, 1 through 10. I mean, 0 through 9, not 1 through 10. So you have 10 times 10 times 10, or 10 cubed, which equals 1,000. Now what you'll do is, since the 2 letters and the 3 digits are together, you're going to multiply 676 by 1,000 and get 676,000. Now, that's just looking for 2 letters followed by 3 digits. We also want to look for 3 digits followed by 2 letters. So since they're exactly the same, all you're going to do is add those together, which means there are 1,352,000 possibilities in different license plates as long as repetition is allowed. So since we know when repetition is allowed, Skylar, can you explain to us if repetition is not allowed, how you would figure this out?
Okay, so repetition not allowed. So that means we have the 26 letters in the alphabet. You can choose any of the 26. So let's say I choose A, but for my second letter, I can't choose A again. So I have to choose another one. So that leaves me only 25 options. So you would do 26 times 25, which is 650 just for your letters. And then for your numbers, it's the same thing. So if I chose 7 for my first number, which is, you're not allowed to choose a license plate, but whatever. So I only have 9 options to choose from. So it's 10 times 9 times 8 because I have 3 digits, which is 720 options. So if you multiply 650 letters that you can choose from times 720 numbers that you can choose from, that comes out to 468,000 options for a license plate. But like Heather said in the previous, you have to have 2 letters and 3 numbers, or 3 numbers and 2 letters. So that means you have to add 468,000 plus 468,000, and that gives you 936,000 possible license plates.
Which is a lot.
That's a lot. Okay, well, I want to say thank you guys for watching our video. We had fun. It was crazy. Bye.